Sound is energy in motion, a mechanical wave. Unlike light, which can travel through a vacuum, sound needs a medium, air, water, or even steel to move. When something vibrates, like this tuning fork, it pushes air particles together, compression, and pulls them apart, rarefaction. These pressure changes travel outward as a longitudinal wave. The particles move back and forth in the same direction as the wave. Let's break down the main features of a sound wave. Frequency, number of cycles per second, measured in hertz. This is what we hear as pitch. Wavelength, the distance between two consecutive compressions or rarefactions, measured in meters. Amplitude, the maximum displacement from the rest position, how tall the wave is. This is loudness. Speed, how fast the wave travels through a medium, measured in meters per second. The speed of sound depends on the medium, faster in solids, slower in gases. The most important formula in acoustics is speed of sound, V, equal to frequency, F, multiplied by wavelength, lambda. This formula tells us that the speed of a sound wave equals its frequency times its wavelength. If you know any two, you can always find the third. Suppose you're at a concert and the singer hits a note at 880 Hz. The speed of sound in air is 343 meters per second. What's the wavelength? The wavelength, lambda equals V divided by F, tells us how long one wave is. Lambda is the wavelength, V is the wave speed, and F is the frequency. So, if a wave moves faster or has a lower frequency, its wavelength is longer. Frequency and period are closely related. The period T is the time for one complete cycle. If a sound wave has a period of 0.002 seconds, what's its frequency? This formula shows how sound speed changes with air temperature. At 0 degrees Celsius, sound travels at 331 meters per second. For every 1 degree Celsius increase, it goes 0.6 meters per second faster. Let's find the speed of sound at 30 degrees Celsius. Plug the temperature into the formula. V equals 331 plus 0.6 multiply 30. That's V equals 331 plus 18, so the speed is 349 meters per second. When you shout and hear an echo, you can measure distance. This formula finds how far away something is using sound. V is the speed of sound, T is the total time for the echo to go there and back, so we divide by 2 to get one-way distance. You hear your echo 2.5 seconds later, speed of sound is 340 meters per second. Using the formula distance equals velocity into time, divided by 2, we plug in V equals 340 meters per second and T equals 2.5 seconds gives us 340 into 2.5. Divided by 2 is equal to 425 meters. So, the object is 425 meters away. What is sound intensity? Sound intensity refers to the power per unit area carried by a sound wave as it propagates through a medium. It is a measure of how much energy the sound wave transmits in a given direction and is typically expressed in watts per square meter. Formula for calculating sound energy. Sound intensity decreases as you move away from the source. A speaker gives off 0.5 watts of sound. At 3 meters away, the intensity is I equals 0.5 divided by 4 pi multiply 9, which is about 0.0044 watts per square meter. Sound spreads out, so intensity drops with distance. What is decibels? A logarithmic unit used to measure sound intensity or loudness, which compares a sound's intensity to a reference level. We hear loudness on a logarithmic scale, the decibel. To find sound level in decibels, suppose we have a sound with an intensity of I equals 1.0 multiply 10 raised to minus 6 watts per square meter. Now plug it into the formula. We get dB equals 10 multiplied by 6 is equal to 60 dB. The Doppler effect is when the pitch or frequency of a sound changes because the source of the sound is moving toward or away from you. When a sound source moves toward or away from you, the pitch changes. This is the Doppler effect. An ambulance siren emits at 700 Hz, approaches at 30 meters per second. Speed of sound is 340 meters per second. We're using the Doppler effect. A sound source at 700 Hz moves toward you at 30 meters per second. Since sound travels at 340 meters per second, we plug into the formula. We get equals 700 divides by 0.9118 and frequency about 768 Hz. The pitch sounds higher. Musical instruments use standing waves. The speed of a wave on a string. Length of string is 1 mass 0.01 kilograms, tension 100 N. First, calculate linear mass density. Mu equals 0.01 kilograms divided by 1 equals 0.01 kilograms per m. Then use the formula V equals square root, T upon mu. Mu equals 0.01 divides by 1 is equal to 0.01 kg slash mv equals square root. 100 divides by 0.01 equals 100 meters per second. That's the wave speed. Acoustics explains everything from music to medicine, gaming to nature. You can experiment with sound using stuff you have at home. If you want to go deeper, check out In Tech Online. They've got awesome articles, guides, and real-world stories that make the science of sound come alive. Until next time, keep your ears open and your mind curious. Hit up intechonline.com and start your sound journey now. Don't forget to like, share, and subscribe. Press the bell icon and stay updated to fuel your curiosity. Discover more at In Tech Online.